When my coding agents write TypeScript, they're using effect. And it's not because they're functional programming pedantics sitting atop the ivory tower of academia. It's because I'm prioritizing correctness when I'm coding with agents. Now, typically if I'm coding my own project, I'm never writing unit tests. I'm using static analysis tools like TypeScript and linters like Biome. And static analysis, when it comes to agentic coding, really does make a difference. I have a lot more success writing TypeScript than I do with some dynamically typed language like Ruby. That being said, static analysis is not enough for me to feel confident about what the agent is doing 100% of the time. So when I'm coding with agents, I want them to cover their code with tests and even use test-driven development, so write the tests first before implementing the code. And I found that effect is a really easy way of getting your agents to write testable code. If you've written software at all, you know that writing testable code is an art in and of itself. Not only are you trying to get the code to do the thing you want it to do, but doing so in a composable way that you can test and isolate is a craft. And Effect is an amazing framework for facilitating that. So not only does Effect facilitate patterns like dependency injection, but it also provides a huge standard library for a lot of the functions, the basic functions that you would see in like a functional programming language like Haskell. And when you use pure functions, you're also just preventing that many more errors that would be caused by side effects and sort of the more imperative programming model. Finally, Effect is making errors explicit in the type system, which is amazing. Typically, when you're writing TypeScript, you don't know whether a function is going to throw or not unless it's well documented. And so potentially you have to wrap everything in a try-catch, which is just a horrible feeling. And in Effect, not only do you know whether a function is going to throw, but you know exactly what kind of errors it can throw, and you can handle each one accordingly. Now, one of the hesitations you might have with using Effect with agents is the lack of training data. So Effect is fairly new and probably not a lot of training data for teaching the LLM how to write Effect. But I've actually found this to be a non-problem. First of all, the docs, the official docs, have llms.txt that are searchable and linkable here on the website. I also recommend using the context7 MCP and hooking that up with your agent. And so it can just search for the Effect library and it can read through that lms.txt here. There's a great website called effect.solutions, which I'll link in the description. And it actually recommends that you clone down the Effect library repository into your own repository, like use a git submodule. And that way, when the agent wants to look at the surface area of the library, it can just grep through the source code. Finally, whenever I'm using agentic coding in a project, I'm always handwriting the first couple, in this case, backend routes. So here's an API, and I'm using the controller service repository pattern, which you can find more about on my channel. But essentially, I've handwritten these first couple controller functions, and now the agent can look at those as precedents for the style that I want and replicate those out throughout my entire application. And so I think spending the time up front to set the precedents for the style that you want replicated throughout the rest of your program is a really good idea in the age of AI. It's sort of an upfront cost, but a long-term investment. Now, getting back to the actual benefits of Effect here, if I just inspect the signature of this create creature function, you can see that it returns this effect type, and it's got 3 type arguments. One of them is response, and then there's a never here, and then we have session and creature service. And so really quick, this first type argument represents the actual result type. In this case, this is a controller, so it's going to return an HTTP response to the caller. Now, the second one here is actually the error types, and I'll show off what that looks like. But because I have this method, let's see, I'm calling this function handle creature error here. It's actually handling all the errors. And so we know that actually this function, minus anything that I haven't accounted for, any errors that I haven't accounted for, is never going to propagate up an error, which is a pretty good guarantee to have, right? Like the never here means that it's never, any error that gets propagated up is something that I wasn't accounted for, it was not baked into the type system, and is what the Effect library would call a defect. But in this case, I'm handling all the errors that I know to handle, and so there's a never here in this type argument. And the last one is actually the dependencies of this function. So let's actually go back to the effect.solutions website and talk about those dependency types. And so you'll see here at the top that it mentions dependency injection. And Effect is facilitating dependency injection, facilitating that pattern in your application. Now, I've already talked at length about the benefits of dependency injection, especially when it comes to writing testable code. So I won't discuss it further here, but I want to talk about how Effect promotes dependency injection. And so it has 2 concepts. The first is a service, and a service is a lot like an interface. It's a contract. It doesn't specify an implementation, but just what methods an implementation of the service need to define and implement. So we see here the example it gives is a database service, and this service has two methods on it. The first is query, and the second is execute. Now notice there's no actual code here. Effect.effect is a type, and so it's just saying that it takes some SQL string and produces an effect. Now if we go down here, it actually talks about test implementations, and so this is where it starts talking about layers. A layer is an actual implementation of the service contract. And so much like an interface is a contract that is implemented by a class, which is an implementation, a service is a contract that is implemented by a layer, which is an implementation. And so in this case, they define a test layer, which is a layer, and all it does is it provides those two query and execute methods you can see here. But those methods are just producing some fake data. Here it's just a bunch of fake records. And here it's just console logging the execute. So going back to my application, which really quick, I'll just show off. It's a habit tracking application where you have a ranch or a farm of creatures, and each creature represents one or more habits. And the way you raise those creatures on your farm is by making progress towards your habits and your goals. This project is still very early phase, but I've been working on it. It's a full stack application, and I'm excited to give more updates about it in the future. But diving back into the code here, I have an example of the service and layers. If I go to creature service, and I go down here, we can see I define a creature service, which has a contract. And this contract is create creature, get creatures by user ID, right? So this service is responsible for CRUD operations on creatures. And you can see I have two layers. I have this layer here defined. This is the real live one that I'm using in the application. And then this is a test layer that I can use to mock the service in tests. Now, the implementation of this live layer, you can see it has real methods that are accessing the repository, creating creatures in the database, and that's what's being created here with this layer function. If we look at the signature of this layer, we can see that it's a creature service implementation, and it depends on a creature repository implementation. And so this is awesome. We are specifying the dependencies of our layers, of our implementations, in the types of the layers themselves. If you've worked in unfamiliar code bases before and you've looked at functions and you didn't understand all the dependencies or some of them were implicit, you know how complicated it is to reason about that code. But here with effect, the dependencies are made explicit in the type system, and you know when you go to test that what implementations it expects, what dependencies it expects. And the way that effect knows that a creature repository is required here is because we use this yield creature repository syntax here, which says this function, this layer, depends on some implementation of creature repository. Now, creature repository is itself a service, and it has itself a live layer, which is a real database here, or a test layer, which has just some fake methods on it. But you can see now how you were using this indirection of programming to interfaces into contracts as opposed to real implementations, so that it's very pluggable. You can plug in a real repository, a fake repository, you can plug in a real creature service layer, or here's the fake creature service layer down here, this test layer, that again is just kind of producing dummy results. But notice that this test layer here, if I inspect it, it does not depend on anything. It has never as its last type argument for the layer. And we can see it's because it doesn't yield any implementation, or rather it doesn't yield a service. It doesn't depend on any implementation in its code. And so the question you might have then is, well, how do all these layers, how do all these implementations come together to run the actual application? On the Effect Solutions website, we have an example of this where our app layer is a bunch of calls to layer.provide. So we're merging all those dependencies together and we're providing it into the actual program. We're using this effect.provide function and giving our effectful program the real dependencies here. So if I go back to my code, I have a file runtime that is doing exactly that. It's merging together all of the dependencies, the real repositories, the real database, the real services. It's going to merge those together, and it's going to build one big layer. Now this layer, as you can see, has a bunch of implementations associated with it, but notably it doesn't have any dependencies itself because they're all provided and satisfied here. And finally, I take all these layers and I merge them together and I provide it to this runtime. And this runtime is just the encapsulated way of running effects. So I can take this app runtime and I can run effectful functions with it, and implicitly it will pass along all these dependencies and run the effect functions with the real dependencies. And the way I'm doing this, first of all, is I have an app.ts file, and there's a function, create app, that takes a runtime, and for each route runs the handler as a promise. And so it's taking, for example, that create creature function, and it's providing all the necessary dependencies to it and running it as a promise, and so it can be used in this Hano context, in this Hano app, as a real route handler. But the exciting thing is that this runtime, like, it just needs to provide the service dependencies, but it doesn't care like what layers you actually provide it. The runtime isn't specific to the implementation, but just to the contracts. And what that means is that now we can write integration tests. Like here I have a create test app. We can see that this create test app function uses a real habit service layer, but provides a bunch of test or fake layers for the other services so that we can isolate the business logic of the habit service. So here we have a fake repository, we have a fake creature service, which isn't actually under test in these routes, and we have fake environment variables here. Again, we just make a runtime and we pass in all those merged layers, and we're able to call create app with that, which again is just going to register all of the app routes. So it's pretty cool. I mean, this create app function together with the layers, the services, and this runtime, I can now plug in and swap out different layers depending on the environment that I'm in. Okay, so all that being said, it's really easy for me to mock out dependencies in tests and get the AI to do that, so that when it comes to actually writing the test, for example, for create habit, there isn't actually that much to be written, and it's really easy to sort of reason about what these tests are actually testing. So hopefully that was a pretty good demonstration of why I would use Effect for the dependency injection framework. It makes testing a lot easier, and ultimately it's going to facilitate your AI writing better tests. Now the other thing I'll show is those explicit errors. So if I go back to creature service and I look at the live implementation of create creature, you can see that this function possibly returns in its second type argument a database error or a parse error. Now the database error comes from creating the creature in the repository. The parse error comes from mapping the creature from the database entity to the actual domain model. But you can see here that in rename creature, there's a possibility for a creature not found error. And this gets yielded and wrapped with effect.fail. And so now effect knows, if I look at this type signature, that this function can potentially return a creature not found error. And so that problem before of not knowing whether a function is going to throw or what kind of error is going to throw is solved by baking the error types into the type system. Then in our creature controller, we can look at rename creature, and we can specifically inspect this handle creature error function, which can look at session error or creature not found error and give the correct response body accordingly. So here, creature not found returns a not found response. Okay, so I didn't want to ramble for too long in this video. I just wanted to provide a high-level overview of how you can use Effect with your agents and why you should. Again, I think it's really important when you're coding with agents to cover your code with tests, because even if your agent is correct the first time, if it makes some changes and makes a lot of changes over time, eventually the system might break in one way or another. And those unit tests, those integration tests can help prevent, things that are breaking, or at least demonstrate to you that some part of your system has changed when the agent has changed some part of the code. Anyway, I hope this was useful. And if you want more depth into Effect and how I'm using Effect and some of the best practices, or just learning Effect in general, perhaps some tutorials, please let me know in the comment section below. But otherwise, subscribe. I'm excited to provide more content, more devlogs for this Habit Hatchery app in the future. But anyway, that's all I have today. So thank you so much for watching the video. Again, please subscribe, and I'll see you next time. Take care.